Good morning, welcome back to SAS From Scratch. We're still at episode 14, albeit this is episode 14B because episode 14 is quite large. And so last time we looked at all the date and time functions, and this time we're going to be looking at all of the string functions. So SAS has quite a lot of built-in string functions, and as we said last time for the date functions as well, you tend to just use what SAS has in its toolbox. So it's not as easy as with R to just go and download the package to do something specific. You kind of have to make do with what SAS gives you, with some exceptions. But for the most part, if you're starting out, if you're new to SAS, you're going to be using what SAS has provided to you. And just to be clear, that for the SAS base exam, the date functions, the string functions, the numeric functions that we're going to be looking at are all just a very, very small subset of the functions that are actually available in SAS. If you want to see a full list of functions that are built into SAS, you can do so by going to the SAS online help and documentation page. And it'll have like a sidebar, and it'll just list all of the built-in functions, and there's hundreds, if not thousands of them. So if at any point you feel maybe a little inhibited or stunted by what you've learned from me or from the base prep guide, the place to go to would be the SAS online documentation site. And you're probably likely to find whatever function you're looking for to make your life easier, because there is almost a function for anything that you would want to do. Without further ado, let's get started. The first function that we're going to be looking at is the scan function. Now in the syntax here, this argument is a string that you would provide to SAS. So let's imagine the quick brown fox jumps over the lazy dog. I can't remember the sentence, but something along those lines. So you could pass that sentence to SAS, and you could ask SAS for example, the second or the third word from the string. So if we imagine the quick brown fox, if we pass 4 and that whole sentence, the is the first word, quick the second word, brown the third word, and fox is the fourth word. And so if we pass that number 4, we're going to get the fourth word, which is fox, back from that string. You can specify specific delimiters that you would like as well. So I think normally the default delimiter is a space. You might choose to use, for example, a comma or dash or a pipe or whatever it might be, whatever your string is separated by. It could be, for example, that you have both spaces and commas, or a mixture of things, so you can put in all the different delimiters that you need into this function. And there will be some examples, I think, in the base prep guide. I'm not going to, we're going to run out of time if I need to provide an example for each and every one of these functions. But I do want to go over them, and you can go and practice them in your own time, or you can look up the examples in the base prep guide. One thing just to note here is this N, which is like first word, second word, third word, etc. 1, 2, 3, 4. If that is a positive number, SAS is going to move through your string from left to right. If that is a negative number, it's going to go from right to left. So for example, if you say the quick brown fox jumps over the lazy dog, and you ask for word -1, that's going to give you the first word from the end back, which is dog. You can specify modifiers after the delimiters. We'll take a look at modifiers for the compress function further down. but I don't want to get stuck on them for the scan function, because the modifiers for compress and scan will overlap in places, and once you understand how they work for the compress function, which is actually inside the scope of the exam, you will have a good idea of how to apply those modifiers to the scan argument as well. But modifiers for the scan function specifically, I don't believe are applicable to the SAS base exam. So I don't want to get stuck on that now. For now, just be aware that this is a function which can give you a particular word from a string based on its index. That's a scan function. It can be useful in certain cases. You might use it on a limited basis, or you might use it very regularly. How often you use it, of course, will determine how deep you want to go into its manual and what's the word I'm looking for? Specifications and all that. Moving on, the substring function is another very useful function. So this works a little differently from other languages. So I guess it depends on the language. So in some languages, I believe in R, the base substring function would be based on a start position and an end position. In SAS, it is based on a start position and in a certain length. If you do not specify that length, it will just take all the remaining characters from the argument. So this argument is your string that you're passing. You provide a starting position. The index starts at 1, not 0. And a certain length. So you could do, for example, and maybe the best way of doing that is with an example. I've already got a little exercise prepared, so I'll just start something new. So if we just do something like this, there's better ways of doing it. You can just do it with a put as well, but let's do it in a data step. Let's just say my string equals ABC 1 2 3 D E F. Let's do something like this. If we then say my substring equals the substring of my string, and let's start at position 1 2 3 4, and we ask for 3 characters in length. So we start at position 4 and we continue for 3 characters. That should give us 1 2 3, unless I've got my indexes messed up. I don't. So that is the substring 1 2 3 of this longer one. Now the substring function will always give you a string back. So you can see my substring, even though it contains only digits here, is still a string. And that's the case for all of the character functions. With some exceptions, for example, the index function, which gives you the index of a particular word or string or character. But if you're using substring or compress or whatever, even if it gives you only numbers back from the string, they're still going to be in the character format. The very useful thing that substring can do is it can replace text. So you can use it as sort of a get operation, but you can also use it as a set operation. So for example, in this case where I said, well, my substring is from 4 character to 4 for the length of 3, I can also do something like I should be able to do something like this, which is to say, in my string, for position 4 length 3, replace with this XYZ character. And so by using it as a set operation, we've now replaced within the biggest string, in that substring, a certain number of characters. So ABC 1, 2, 3 DEF became ABC XYZ DEF. And that's very useful. Not a lot of people, I think, sometimes know about the fact that substring can be used as a set operation as well. That's the substring function. I think it's fairly straightforward. The last, not the last one, the next one we're going to look at is the left, right, trim, and strip functions. Now they're all sort of related because they all have to do with leading and trailing blanks. So if you've got something like, for example, let's put a couple of blanks here, let's put a couple of blanks there. If we do, so let's go back to the slides. I'm sorry, I'm going too fast through this. So if we pass a string to the left function, any leading blanks that we have are going to be shifted towards the end. If we pass a string to the right function, then it's going to right align the characters and move any trailing blanks to the start. The trim function is going to remove only trailing blanks, and the strip function will remove leading and trailing blanks, but it will not remove spaces that are in between characters. So if you've got, for example, something like this, the strip function should not remove these characters in between. It should only remove these blanks at the start and at the end. And so we can test this. For example, we can say that left is left my string, right equals the right align of my string, trim is my string trimmed, and strip is my string stripped. And if we run this, we can see, for example, we had a limited number of spaces here at the start. We now have no spaces at the start, but we should have, oh, we should have had some spaces at the end, but it might just not show that in the viewer. So I think there's no spaces at any point in the viewer towards the end, but in the underlying data set, if you work with that data, there should still be spaces at the end here. Just watch out for that. And then for the one that was right aligned, you can see the spaces were moved from the end here to the start. You'll notice there's more spaces there than for the original string. If we trimmed it, there's still a space here at the start, and I wonder why that is. Of course, because trim removes trailing spaces, it does not remove leading spaces. And then for strip, you can see we've got no spaces leading or trailing, but the spaces that are still in between the different words have been preserved. So that's the difference between all of these. Some people prefer to do, for example, my preference is just to do strip. Some people prefer to do, for example, left and then trim. Apologies, that's the wrong way around. So first you would left align it, then you would strip it, and they prefer to do this to strip all of the extra blanks from it. I prefer just using strip. So that's the left, right, trim, and strip function in action. And like I said, they're all sort of related because they all have to do with the blanks and what happens to them. Concatenation with SAS is fairly easy. So these are so that's double pipe. In some languages, for example, like Java, C#, I think C, you would use the double pipe as the OR operator. And the you would use double ampersand as your AND operator. Now in this case, the double pipe operator is the concatenation operator for SAS. So if you wanted to combine, for example, a first name, a middle name, and a last name, you would do that with the double pipe operator. However, the problem is if you have, for example, what we had here, if you have a bunch of extra spaces, trailing and leading, etc. in your strings, then that's also going to bring all those extra spaces along. I believe also what it might do, and I'm speaking under correction, you can go and try it out for yourself. If you've got, for example, a character of length 10, but you're only using 4 or 5 characters of that reserved 10 bytes of space, then when you concatenate it, it's actually going to bring whatever the 4 characters are and 6 extra characters spaces to make up the 10 characters that it expects. And so you would have to strip these each. You would say strip first, concatenate, strip middle, concatenate, strip last, to avoid all of those extra spaces being concatenated into the full name variable. There is a different way to do it as well, and we'll look at, I think it's the next function coming up. But for now, just note that if you use this double pipe operator, it can be a little finicky to work with sometimes. The CATX operator is a better one in my opinion, because CATX will remove the leading and trailing blanks, and it will also allow you to put in a separator of your choice. So the separator is the first argument going into the CATX function, and then all of your strings, and you can pass as many strings as you want separated by commas. I think there's an option, there's just a cat function which will not remove the leading and trailing blanks, but CATX will, and that is the preferred function to use as well in most day-to-day cases, at least in my experience. This is the better way to create, for example, full name. So you would say full name equals CATX, open parentheses, put a space here in between quotes, and then first comma, middle comma, last, and that's a much cleaner way of doing it. Moving on, we get to the index and find functions. So these basically allow you to find a particular word or character, whatever it might be, within a larger string. So you can, for example, have the quick brown fox jumps over the lazy dog, and if you search for fox, it's going to give you the starting occurrence of fox within that longer string, whatever that might be. It's probably around the quick brown fox. It's probably going to be around the 15th or 16th character thereabouts. And so it'll give you that excuse me, it'll give you that starting position, and that it gives you that back as a number, a numeric value, and you can then, if you know the index at which it starts, you can do certain things with it. So maybe you want to get a substring or whatever the case may be. Excuse me. But that gives you the index back, as the name implies. The find function does a similar performs a similar function. It returns the starting position of the first occurrence of a string within a character value, which is the same as what the index function does, but it allows modifiers to be specified. So you can ignore the case, because index is case sensitive. So if you specify I in quotes as your modifier, then it will ignore the case, or you can specify a T as the modifier. You can either do I or T, you can do I and T, and I think there's even a couple more modifiers that we can put in. But for now, just be aware of these two for the scope of the SAS base exam, and you can specify a starting position. So for example, if you have the quick brown fox jumps over the lazy fox, and you have two cases of fox and you want to see if there's one after the first one, you would simply tell it to start searching after the first occurrence of the first word fox. So this is just a more versatile index function. In most cases, what you would use something like index for is just to make sure whether a particular string is present within a larger string. So one thing we might use it for is if you've got a list of conmeds, you could search for a particular conmed in that larger, bigger string of conmeds. Maybe they're separated by spaces or whatever the case may be. Sorry. And you can then say, yes, it occurs or it doesn't occur. Now, it does say that the index function is case sensitive. You can work around that. So if you're coming from a computer science background, you would have learned little tricks like this before, which is simply to say, so let's use our my string as an example, and you would simply do something like this. So for the index function only, and only for the purposes of the index function, so we're not actually touching this underlying string at all, but we upcase it just for the comparison, and we upcase whatever we're looking for just for the comparison, so that we're comparing upcased with upcased. If you're not concerned about that, if you do want it to be case sensitive, so in other words, DEF lower is not the same as DEF upper, then you would simply take this out. But there are little tricks to do that. And you can see that DEF starts at 12, index 12. Okay, that's it, I think, for the index and find functions. They're fairly straightforward. Now we get to upcase, lowercase, and PROPCASE. So let's maybe try something else. We can say the quick brown fox. And if we then do upcase, lowercase, and PROPCASE for each of these, we should get, let me just see here. So let's do upcase equals upcase of my string, and this is all self-explanatory. I probably don't need to go through all of these in such detail, but you know, that's the point of the video. PROPCASE and so if we run that, we take, this is our original string. Uppercase will take all the characters to uppercase. Lowercase will make everything lowercase, and PROPCASE, because we had a that we kept the default delimiter as space, after every space it will upcase the first letter of the word. You can specify different delimiters, for example a full stop, a comma, whatever the case may be. In this case we just kept it as the default, which is space. So that's quite easy to understand. TRANWRD is similar to what we did earlier with substring, in the sense that it will replace a bit of a string with a new string. But in substring we had to specify the start and the length of how far we want, so basically a start and an end position for all intents and purposes. Whereas with TRANWRD, it will find all the instances of a particular string and it will replace it with a different value. So we can say, for example, if we say Jane went back to Jane's house, and we say new string TRANWRD my string, and we want to replace all instances of Jane with John. We can do that, and we get John went back to John's house, Jane went back to Jane's house. So that's a quick and easy way of just replacing a particular string in a larger string, or you can even replace the whole thing if you wanted to. But that's the example for TRANWRD. Again, very useful, something you would probably use quite often, and I think straightforward as well to understand. COMPBL, again, something that's extremely useful, because if you have something like this, it will remove all of the extra spaces and simply concatenate it to one space. So you wouldn't need to worry, are there 2, 3, 4, 5 spaces in here? You would simply pass it to the COMPBL function, and it will reduce all of these multiple spaces to a single space. So if we do that, you can see all these extra spaces that were in here are reduced to a single space. Very useful if you're dealing with data that maybe somebody else has typed and they've accidentally hit the spacebar more than once, whatever it might be, to just quickly clean up that data without worrying too much about it. Also very useful if, for example, maybe you're dealing with something where you need to replace spaces with underscores and you don't want multiple underscores where a single underscore will do. So in that case, you would COMPBL the string to make every space only length of one space. And then you could TRANWRD space to an underscore character to make each space an underscore. The compress function, I think, is the most complex one we're going to be looking at today, and it's very important to understand how compress works. I think a lot of people don't always use compress to its maximum potential, and they simply use it as a way of getting rid of spaces. So the compress function takes 3 arguments. You've got your main source string. So that's, for example, my string that we had here in our example, so something like this. Let's do something like, I'm trying to think what I can put in here. And so let's do this. So let's do Jane's telephone number is this, and we put that in there. And this is now the string we're dealing with. So my string would go in as the source to the compress function. And compress will remove certain characters from the original string. So we can say, for example, if we wanted to remove, let's say, this dot, and we'll look at more complex examples, but if we do something like this, it will remove the dot. So it has compressed the dot out of this string. If, for example, we don't specify the dot, by default it will compress all of the spaces out of the string. And this is useful if you don't want spaces in between different words. So we've seen, for example, how we can trim it to remove the trailing spaces but not the leading spaces. We've seen how we can strip it to remove the trailing and leading spaces. And now if we compress it, we remove leading spaces, trailing spaces, and all the spaces that are in between. And that's one of the simplest ways of using the compress function. We can, as we've said, we can combine this with specific characters as well. So if we say, for example, we don't want E and now I'm trying to think if, so let's say we don't want E and R, and we run this, it will remove all instances of E and all instances of R. So it is not removing it is removing E and it is removing R. Hopefully that's straightforward. The thing that makes compress really special is the presence of the modifier argument. And that's something that when we looked at our very first function today, the scan function, I said we're not going to worry too much about modifiers for scan because we're going to come and look at them for compress. And once you know how they work for compress, which is in the scope of the SAS base exam, you'll know how to apply them to the scan function as well. So this is very important to try and keep up with because it does work a little bit strangely compared maybe to other languages that you're used to. So we already know if we pass only the first argument, so if we say compress and a string and we close the parentheses, we remove all the blanks from the argument. You can pause the video and you can read the rest of this just to make sure you understand what will happen if you pass nothing to the argument, and what happens if you have something that you already have a length for and you say something equals compress, open and close parentheses with nothing in between. It'll just fill with blanks, but take the time to read through it and make sure you understand it. Excuse me. If we pass only source and characters, then all the characters that appear in the second argument are removed from the result. So bear in mind that's what we did here. And it does not search for the string as a whole. It searches for each character that we specify in the string. And the last thing that we're going to look at are modifiers. So on the next page, we're going to see a bunch of modifiers and we're going to understand how we can use them. And that goes into the third argument. Now, if, for example, I want to look at modifier k for the moment. Excuse me. K will keep the characters that we specify instead of removing them. So, in the example we had here, where we removed all instances of E and R, if we wanted to keep all instances of E and R, we would pass the keep or K modifier. Now that can be a lowercase k or it can be an uppercase K. It does not matter. And so you can see here we're keeping only the E's and the R. So these are all the instances of E and R that were in this string. We can, for example, if we say ignore the case, so that's with I, so with the I modifier, we can tell the compress function we don't care about the case we're looking at. So we can put it at the end, we can put it at the start, it doesn't really matter. And if we then change the case of this to uppercase, whereas the compress function would, I believe, not normally compare, well, we can just check. I'm pretty sure this doesn't work. Yes, it finds nothing because it is case sensitive. So if we add the I modifier, then it ignores case and it once again keeps only the E's and R's that we wanted. We can, for example, add so there's alphabetic characters, control characters, digits, that's just your numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And I'll show you a quick example of if you wanted to keep a particular number with a decimal as well. We can look at that. We can add the underscore character and English letters to the list of characters. Just ignore this bit that I should have taken out. Graphic characters. I'm not sure if that's like ASCII, particular ASCII characters or wingdings or whatever that might be. Just Google that. I don't know on the spot. Horizontal tab, that's your tab space, I think. Ignore characters, keep characters. You can choose to keep all lowercase letters. If you specify lowercase or uppercase L, you can choose to, so that's either remove or keep, depending on whether you've got the K modifier. All uppercase letters will be U. You can trim blanks from your first and second arguments. You can add punctuation marks, space characters. So for example, if we add space characters to this, it'll keep all the different space characters. You can see, for example, in the first word we had Jane, so that's Jane's E there. Telephone, that's all the 3 E's that appear in telephone. And number, ER, that's the ER that appears in the word number. And so you can see if you keep adding different modifiers, you keep getting different results. Now, this can become quite useful because if, for example, you have something like aspirin 10.5 milligram dose, and you would like to only extract the dose from this string, the compress function is super useful for that, because you can say my dose equals compress my string. You can leave this argument blank for now, and you can say I want to keep the digits. So K keep instead of remove, and D digits. So if we take out the K, it would remove the digits 1, 0, and 5, and would keep everything else. But because we're telling compress that instead of its default function of removing, we want to keep, it's going to keep 1, 0, and 5. So let's run that. And we get 105. That's obviously not correct because it should be 10.5. And then the only other thing that we tell compress is we want to keep the dot as a character as well. So we're keeping this list of characters that we specify, and we could have put in like a comma and whatever else, but we're not worried too much about that now. We're keeping a dot, and in addition to this list of characters that we specify, we also want all digits to be kept. And if we run this now, we get back 10.5. Very easy way of extracting information from a larger string. One thing to keep in mind is compress, even though this is all numbers, compress will always return a character value back to you. So if you wanted to convert that to numeric, and we looked at this, I believe, in the episode on formats and informats, maybe that was episode 12, you would know that you can convert from a character to a numeric with the input function. And if we just bring that in, you'll see there that my dose is now a numeric function, and you can do stuff with dose. You can multiply it by weight, or you can divide it by 2, or whatever the case may be. But the workhorse in this example is the compress function. You can use regular expressions in SAS. It uses, I believe, Perl regular expressions. I have used it myself on occasion, but in most day-to-day cases, a good understanding of the compress function will get you the same results as a regular expression for the most part. So you should know most of these modifiers. You may be asked, I believe, in the SAS base exam to use the compress function with a certain list of characters and a modifier to achieve something. So it'll give you maybe one string and say, how would you get the second string from this first one? So go through all of these. You do need to study them for the exam and play around with it in SAS, in your SAS installation as well, whether you've got maybe SAS at work or at your educational institution, or if you don't have it at any of those two, you can get SAS on demand for academics like I have here. I think that about wraps it up for today. So we've got a quick exercise that I want to go through, and we've already done almost all of these. We've done some examples for. So if we go to, I've made a custom employees data set, and I've written these instructions in the program as well so that it's easy to keep up. But we're going to create a full name column. We've already seen how we can do that, but we'll just do that in code and we'll action that out. And we're going to remove any redundant spaces that might occur. It shouldn't if we use the CATX function, but if we use the normal concatenation operator, we may find some redundant spaces. So for the telephone number column, we're going to remove any leading zeros from the area code. We're going to remove any non-digit characters from the telephone number except the plus symbol. So maybe this is for like an SMS portal or something, and the system expects it to be all digits, and maybe the plus symbol for the country code is expected. And then we're going to make sure that the job title column is PROPCASE. So let's go and take a look at the data set. I'm going to just discard this program. This is what our data set looks like. So we've got John James Doe, and we've got Mary Smith, no middle name. And they've each got a date of birth, which is, let me move myself over. They've each got a date of birth as well, which is unnecessary for this example, but it creates the impression that this is a real HR or payroll system. They've got a telephone number, it has dashes, it has parentheses that we're going to get rid of, and we're going to get rid of the leading zero in the area code as well. The job title you can see is a bit of a mess, so we're going to remove some of these spaces and we're going to PROPCASE it so that it looks more professional. So let's get on with that. So creating the full name column, that's pretty straightforward. So let's just run through what I've done here. We've got the library map to episode 14b, and that allows us access to this employees dataset in episode 14b. We have that as read only so that we can't accidentally change the source data. We move that into the work library, and we read in row by row each of the 2 rows in this source library. So for the full name, that's straightforward to do. We can do, so let's do it this way first. And we can see what happens. So that gives us, you can see there's a lot of extra spaces in here that have been reserved because we use the simple concatenation operator. There's a few ways we can negate that. We can choose to strip each of these, and it is the longer way of doing it. If we do strip it though, we would also have to provide spaces ourselves. So you can see quickly how just using this concatenation operator can become a little cumbersome. So now we have John James Doe and Mary Smith. Mary Smith might have 2 spaces because there's 2 of these things around her missing middle name. So that's still not the perfect way of doing it. A better way of doing it would probably be to concatenate, wrap the COMPBL function around, and that should get rid of all the extra spaces, which it does. So COMPBL is one way of doing it. Honestly, my preferred way of doing it would be CATX. We can specify our separator as a space, first name, middle name, last name, and if we run that, we get the same result. John James Doe and Mary Smith, 1 space in between each name, and we have our full name column. sorted. This is my preferred way of concatenating strings, but there's nothing wrong with using the concatenation operator as long as you take into account that you're going to get some padded spaces and extra spaces in between in the majority of cases. So for the telephone number column, let's see, remove any leading zeros from the area code and remove any non-digit characters from the telephone number except the plus symbol. So leading zeros are, for example, these in the area code. And the quickest way I can think of to solve this problem is simply to replace bracket 0 with just a bracket. That might not work in all cases, depending on how dirty or clean your data is, but it will certainly work in this case that we have now. So if we say, I'm just going to call it telephone number 2, and let's TRANWRD from the telephone number column, opening parentheses and 0 with just an opening parentheses. And if we run that, we should see that the leading 0 has now been removed from the area code. The only other thing that remains for us now is to keep all of the digits and the plus character, which is easy. And I'm just going to replace telephone number 2 by itself. So what do we definitely know? We want to keep all the digits. So we pass the keep modifier to the compress function, and we say that we want to add all digits into the character list. Now we don't have to do that. We could, for example, do something like this. We could do something like that, and it should still work. And it does. But instead of typing all this out, and you can see how this can become cumbersome, because at some point you want to maybe do all letters of the alphabet, and then are you going to really type out the entire alphabet? No, you'll use one of the modifiers to make it easier. So by specifying this digits modifier, we're doing the same thing as typing in 1, 2, 3, 4, 5, 6, 7, 8, 9. And compress by default removes. The K modifier tells it that we wanted to keep all of these things that are in this list. So the plus and all numeric digits. And if we run this again, we get the same result. Lastly, we're just going to PROPCASE the job title, and we are also going to just probably COMPBL and strip it, or whatever the case may be. So let's say job title, and you can nest these functions as well. So you can PROPCASE your job title. Then you can say, oh, well, I want to strip all the leading and trailing spaces. And just in case there's multiple spaces in between the different words in the job title, I also want to take out all the redundant spaces in between. So you can nest these functions, and we could have done the same thing here. So for example, this telephone number 2 here is coming as a result of what we did in line 19. So we could remove this, we could pop this in there, and it would give us the same result, but it would just be a lot less readable. And we prefer to keep things readable and understandable. So if we run this, we should also fix the job title column. It is now fixed, it's no longer a mess. And we have our full name column and our telephone number column. That's it for the exercise. It's a short exercise, but it's hard to sometimes find the best examples for this. And the best way of learning about all these functions is to go and try them out for yourself. So go play around with the scan function, the index function, all of that stuff. We've looked at some examples today, but that's the gist of what we had to finish for today. So this wraps up all of the string and character functions, at least for the scope of the SAS base exam. There's obviously way hundreds more functions than just what we looked at today. A good book on some hidden or maybe obscure SAS functions that you might not know about, I believe there's a book called SAS Carpentry. I'll maybe try and link it in the description below. But there is a very good book on different functions that are not as well known, but that are extremely useful in a day-to-day basis. Moving on, so next time we will take a look at numeric functions. The chapter in the prep guide is a little bit shorter. I don't think they highlight too many. I've put in 1 or 2 extra ones that I think are useful. And we're also going to look at the of keyword, because the of keyword is extremely useful to do things across multiple columns if they are similarly named. And sometimes not even, they just have to be in a particular order. So we can take a look at that, but that's the next episode's remit. So I would like to thank you very much for watching, as always, for bearing with all of my waffling and rambling. I hope you have a good rest of your day, and I'll catch you in the next episode. Cheers. Bye-bye.